Hello everyone, welcome back. Today in this video I will show you how to create group frequency table, histogram and Ogive graphs for continuous data using R. In doing so, we will follow the following steps of constructing a successful group frequency table, which starts from determining range, determining the number of classes, determining class widths, and ending with the complete frequency table, which consists the common elements of a successful frequency table. Stay with me and let's get started. So as usual, what's the first step in implementing data processing, presenting, and analysis using R is nothing but installing and loading necessary packages for the activities that we are going to implement. So here we begin by loading one important package which helps us to import an Excel data file, to our R session. That is real Excel package. So we load this one. We have already loaded. This is successful. Then we proceed to importing a data file with which we are going to construct these all frequency tables, histogram, and Ogive graphs. So let me import by this code. Then we assign the imported file using this function into HHS variable. Then hit this run. Right, successfully imported now. Now we can work with this HHS now. For example, with our data set in our working environment, the first few rows using head function HHS. Now let us see what it looks like. Wow, this is nothing but we can understand that there are 3 columns, right? Age, marital, family size, with 6 rows, right? No missing values this around this columns, and I can see the last 6 tail using tail function, right? HHS, right? This is nothing but wow, this is the last 6 rows of the data set, and I can see the first 10, right? 10 observations, right? I can write this integer separated by comma. Here, if I hit this run, I come up with these results, right? But we can view the whole data set observations in the form of spreadsheet using view function. View function, HHS, right? Let me run this one, right? This is nothing but the spreadsheet. But this spreadsheet is read mode. We cannot edit here, but we can only view, right? We have another option that we do both view and edit using edit function HHS. This can give us the spreadsheet on which we can edit and view. We can view and edit, right? This, for example, this column is H with type numeric. This one is marital with type character. This one is family size with type of numeric, and you can change this value here, right? Right. The other important function that helps us to inspect and explore our dataset is steer function, to see the structure of the dataset, right? So let us see what the structure of our dataset. This is nothing but data frame on which there are a number of informations related. Here there are 3 columns: age, marital, family size, and the dimension is 800 by 3. The type of each variable is here: numerical, character, numerical, the range of the cases, right? This all can be generated by this steer function. The other thing, we can also see the summary statistics, which is the comprehensive summary statistics by summary function, right? You can see this summary statistics using this function, where for those quantitative variables, this can be generated: the minimum, maximum, the first quartile, third quartile, mean, median, right? If there is any inconvenience with the data set, we can inspect and explore the data set using these functions. Having done so, what the next step is now starting creating frequency distribution, which is group frequency distribution. So what's the first step in doing so is determining the range, right? Let us determine the age range. Right? Age range can be determined by range function, right? The range function of which variable from HHS dataset is nothing but this one, right? Let me run this one, successful. Then let me print what is stored within age range. This is nothing but the minimum and the maximum. Right, this is nothing but the minimum age is 8, the maximum is 80. Right? Now, having determined the minimum value and the maximum value of our age variable, what the next step is obtaining the range by itself, meaning the difference of the two, the maximum and the minimum age. How can we obtain this one? This is nothing but range is denoted, for example, by r. Then we make use of diff function of what? Age range. Right? Then let us see what's the result in r. Print r. Right? Let us see. Now 80 minus 8 is 72, right? Let us see the result, which is nothing but 72. But the next step is determining the number of classes using the common rule, which is Strike's rule. Now let us determine the k. K is now determined. K is related for number of classes. Now we follow the function sharing. Sharing function 1 plus 3.322 times n to the base 10. But we didn't determine n. What is the number of observations of the age variable? This is nothing but the length of HHS of age variable, right? Whatever the length of this variable will be the number of observations under investigation and taking into this function, right? What the sharing function here is, which allows rounding the number up. If there is 10.1, the sharing function rounds up always into 11, right? So sharing helps us to round the number up. Let us see. Let me run this one first, right? N determined by this code, then k determined by the next function, k. Let us see. Print what is k now is, right? This is nothing but 11. So in what follows, we will construct 11 classes, right? Now, having determined the range and number of classes, what's the next step? Determining class widths. Class widths is nothing but the ratio of range to number of classes, right? This is nothing but r divided by k, right? But this can also be take the function sharing function in order to round this ratio into the nearest integer up, not the nearest integer but to round up, right? Always this sharing function allows us to round the number up, right? Let me run this one, right? So let me see the content of the class widths. Print w, which is the class widths, right? Let me see, it is 7, right? Class widths is nothing but. Now let us create both lower class limit and upper limit. Lower limit, for example, can be obtained by this function floor function age range, right? Meaning, right? This is nothing but the lower limit of the first lower limit. The lower limit of the first class can be the minimum value of the data set and below. So what's the maximum that can serve as lower limit of the first class interval is the age range of one position, right? And below, this below accesses this number, and below is achieved by this floor function, right? What will be the upper limit? Upper limit will be the lower limit plus class widths times k, right? This is upper limit, meaning that the upper limit of the last class interval. Here we are determining the lower limit of the first class interval and the upper limit of the last class interval, right? Let me run this, right? Successful, and run the next code, right? So let us see. Print each lower limit. What is the lower limit? Is nothing but 8, right? Upper limit. What upper limit of that? This is nothing but 8.5, right? So the range of our class intervals starts or begins from 8 to ending 8.5, from which we can create the class intervals. Now let us create group frequency table, meaning that the basic group frequency table can be created now, right? Age groups, cat function creates these class intervals, right? Then the variable to be created, the variable to which this group frequency table is to be created is age, right? This one. So what the bricks is nothing but bricks is age bricks. Age bricks. The intervals are created here, edge breaks, right, by the function sequence function, then starts from the lower limit, right, ended by the upper limit by class width of w, right? This is nothing but now the class limits are to be created. Let me see this one. Breadth, edge, breaks. These are the series, right? That can be the series that can be the lower class limit and the upper class limit are within this series. Now let us construct the class intervals, right? This is edge. Now edge breaks is assigned to breaks, right? Edge breaks is the right is false, right? The right hand side is not inclusive in the interval, whereas include the lowest, true, right? The lowest value of that class interval is to be included to that class interval, whereas the right side will not be included within that interval, meaning that the last value of the class interval will be exclusive, right? Let me run this one. Success. Now let us see the value of edge groups, right? These edge groups are nothing but the value of the edge to which class interval is to be included. Then let us create the frequency table here. Edge freq. The basic frequency table is nothing but using table function, right, which takes in the edge group, right? These four edge groups now bring us to the summarized basic frequency table. Let me hit this run and see the result. Print edge freq, right? Let us see this one. Wow, this is nothing but the basic frequency table. Now we have one household whose edge is from 8 to 15. This 15 is exclusive, right? And we have 73 householders whose age is 15 to 22, meaning 21, right? Most of the householders were 36 to 42 years old, right? Let us compute now class limits and class boundaries and midpoints. Lower limits, for example, we can create from the edge breaks of negative length, right, of what? Edge breaks. This lower limit is now it takes value of the first element of the edge breaks, the first element of the class interval or edge breaks. The upper limit is nothing but edge breaks, right, negative 1, right, minus 1, because the right side is exclusive, so we subtract here. So let me run this one and run this one. Then the class boundaries can also be created by lower boundaries, right? Lower limit is minus 0.5, where the unit of measurement is 1. That 1 divided into 2 will have to be 0.5. So we subtract 0.5 from the lower limits of each class interval, right? The upper bounds, meaning that we add upper bounds plus 0.5, right? So let us run this one, right? Therefore, what the next step is computing the midpoint or the class marks, nothing but the sum of lower limits plus the upper limits divided by 2. This is nothing but class marks, right? What the next step is computing relative and cumulative frequencies, right? This is optional actually, but let us see how to compute these all things in R. For example, relative percentage from table, we can compute this relative percentage from the once created frequency table, which is edge freq, right? And we multiply by 100, and we round into 1, right? We round to 1, right? So run this one right? Relative percentage is now created. So cumulative cum percentage or cum frequency can also be created by cum sum function from the RPS function. H, this is created on the frequency table, which is H freq, right? This has also been created now, right? Let us see now. Print this one. Cum freq. You can see this is A. This is nothing but the less than cumulative frequency, right? From 1 up to 800. Now we are reaching to the final complete frequency table, which consists all possible elements that we need, right? This consists age group, which takes the names of the age frequency, the lower limit from lower limits that we have computed above, upper limit similarly we have seen in the above, lower boundaries, upper boundaries, which takes these values, whereas these values are this element as the name of the elements that we are going to create, right, in one frequency table. Right now class mark is nothing but the class markers that we have created above, this one. So this can be created by using the data frame function, which takes these vectors, then we assign to age detailed. So let us see the value of the age detailed by print function. Let us see, right? This is nothing but the complete frequency table now, right? Where this age group is nothing but one possible class limits or class intervals, or the next table, lower limit, upper limit, are the explicit class intervals where from 8 to 14. But this class interval from 8 to 15, but 15 is exclusive. Same language from this one are the same, right? 8 to 14 or 8 to 15 are the same. So we can release this element age group, this one. The lower boundary is nothing but we subtract 0.5 from the lower limit of the first class. This is nothing but 7.5. We add 0.5, this 14.5. The same is true. So these two elements are the lower boundary and upper boundary of given class. The class mark, this is nothing but this element. Frequency, this one. Relative percentage is nothing but this one, right? This one. 0.12 is nothing but 1 divided by 800 times 100. This becomes this one, right? Cumulative frequency is this element. Cumulative percentage, the last element. So this is a complete global frequency table for our age variable, right? Creating graphs needs the knowledge of the frequency table, right? So having determined this age detailed frequency table, now we can plot the histogram using the bar plot, right? By plot is bar plot, right? Now bar plot. So what the next one is plotting Ogive using upper boundaries and cumulative frequency, where cumulative frequency is the y-axis, whereas the upper class boundaries the x-axis, right? So this plot function takes two variables x and y, where x is the upper boundary, whereas the y-axis is cumulative frequency. These two elements are from the age detail frequency that we have seen above, right? Here around from this table, right? The cumulative frequency is this element that we take into this plotting function. These are the decorating elements, right? The main thing is these two, right? So let us see. Let me run this one, then we come up with this plot, right? This is nothing but which is incrementing